It's fine. Let's find some different means, please. Somebody could be taking the other pile too and doing it into their calculator. We're almost there. Almost there. Finding the difference in your sample means. Still, it should just still be group. It doesn't. Group 2 minus whatever you figured it was group 1 and group 2. Okay, it doesn't matter. It could, yes, it could come out to be negative. That's fine. Are we almost ready here to report back? Difference in your means. Everyone all set? Okay, let's report back here. Let's report back. Group over here, what was your difference in your means? 0.35. Let's go around. Just group right up front. Difference in your means? 2.35. 3.2. 1.9. 1.1. Sorry for the gap there. Okay, let's take a look at what we have. First of all, you can't tell me anything because how many did we just do right there? How many reshuffles did we just do? 5. And you guys know as well as I do, is 5 going to cut it in any type of experiment? No, we need like triple digit type shuffles. All right, which we'll get to in a second. But as it looks right now, is my 2.3 out of the ordinary that I found? As it looks right now, is it out of the ordinary? Does it seem unusual at all? Not right now. All right, let's see what happens when we do it 100 times now. So I've already done this, okay? And that you guys have a little histogram there in part B. We don't have time to do it. Just take a look at mine. Here's what I did. I ran all those numbers again, and what you guys just did, I did it 100 times. And this is what I got for a chart. Okay, this is what I got. Can you guys see those numbers down below? Those are, not anymore. Those are the difference in my means. Okay, so negative 3.75 all the way to 3.00. Okay, what was our observed difference again? 2.3. So that would have been about right there, 2.3. Now here's where I don't blame you if some of you guys are going to get a little confused and question yourself. Is that unusual or not to be out that far? Brienne might have an opinion different than mine, different than Matt's, different than Brooks, if that's unusual or not. We need some consistent way to say, yes, that's unusual. No, that's not unusual. Here is the way we're going to go from now on. Okay? Well, actually, I don't want to tell you yet. I'm going to have you guys figure it out. Go back to part C. Of the 100 I just did, and I'll go back to the chart in a second. Of the 100 I just did, what percent are at or above the 2.3 we found? Okay, how many are at or above the 2.3 we found? That's the observed difference. Okay, so out of the 100, how many are at or above 2.30? All right, so let's go back to, everyone ready to go back to my graph? These, I can tell you, and I'm not lying to you, these are all at or above 2.30. That's how many times the difference in the means was above 2.30 or at 2.30. Anybody want to count those real quick? How many times? 10? Everyone's good. So 10 out of the 100 times, it was at 2.30 or above. What percent is that? 10%. For a difference, for an observed measure to be unusual, it's got to be 5% or less. Okay, it's got to be 5% or less. And some people are like, well, how the heck did you come up with 5? Honestly, I don't know where the statisticians came up with 5, but I believe it's something to do with this. Remember doing our confidence interval? What level of confidence was that? 95%. So I'm thinking 5% either way, it's unusual. That's where they came up with that 5%. Okay, so ours was 10% at or above. So is this number 2.3 unusual? Is this an unusual occurrence? Why are you shaking your head? What's our cutoff? Our cutoff is 5%. 10% were at or above. So is that unusual? No, it's not an unusual occurrence. Does everyone see that? If this number was 2%, 7%, actually, sorry, 2%, 4%, then it would be unusual. Okay, everyone see that? We all right? Okay, so 10%, and you might want to just write in here, if less than 5%, we consider the observed difference remember that term I gave you guys on Friday, statistically significant. Okay, if that number is less than 5% outside, it is unusual, which means it's statistically significant. Megan, go. Ooh. I think that if it's 5% or below, it's unusual. So statistically significant. Yep. Okay, so before I answer part D, did those plants grow based on the nutrients or just by random chance then? Did they grow by the nutrients or if this was not statistically significant, it was not an unusual occurrence, did those plants grow by just random chance or by the nutrients we gave them? Random chance. Okay? Do you remember? Whoa, I didn't go over this at the beginning because I wanted to wait for now. Do you remember another term for random chance? Something causes by? Ethan, yell it out. Natural causes. Okay, if it's by the treatment, we call it induced causes. All right? So read the question right now. Go ahead, read it on your own. I don't want to read it to you. Read it on your own. How confident are we that it was induced? Meaning the treatment, meaning the nutrients. How confident are we? We're 100% confident? Okay, well, I don't want to, I just want to say not confident. Okay, so we're not confident. Since what percent? Since 10% of the sample were at or above the observed difference. And what's our cutoff again, guys? 5%. Okay, 5%. If it was 5%, then we'd be confident it was by the treatment and not just natural causes. Perfect. Okay, let's actually just see how far we've come, because tomorrow you guys are just working on your own. Okay, go ahead, read about Gabriel and his plants real quick. I'll get there a bit. There we go. Go ahead, read real quickly about Gabriel, another child who has some free time on his hands. Don't lose those, Vinny. One jab. I don't know if this is going to help you out or not. When you determine if something is statistically significant or not, here's what I saw the other day. I thought it was pretty good. 3 S's. All right, you look for the 3 S's. Statistic. Difference in the means. That's what you're looking for first. Anybody read through the problem there? What's the difference in my means? The difference in the 2 types of treatment they gave. Read through the problem. It's there. Read through it. Don't look at the graph yet. It is 5 ounces. 5 ounces greater than the plants without mulch. So there is what I need to compare to the dot plot now. 5 ounces. The second S, you need samples, which is what you guys did by reshuffling. They did the samples. Here's the difference in the mean weight. Locate where our statistic is. Everyone see where 5 is? Two, 4, right about here. Locate where your mean difference is. There it is, 5. Now let's decide, significant or not. Sometimes you don't need to do the whole 5% test. You can look at the dot plot and notice right away if it's significant or not. Look where it is. Look where it is. It's around the majority. It's around the middle, isn't it? Is that 5 significant or not? Is that 5 going to be? You can count up the dots if you want and do it out of 100, but I can guarantee there's probably a little bit more than 5 out of 100 that are on that side. Okay? Significant or not? What are you going to tell me? Significant or not? Based on where the 5 falls with all the rest of them, significant or not? I can't get the numbers out here. You guys win today. Significant or not based on where that 5 is. Is that 5 unusual? Absolutely not. That 5 is not unusual. Look at everything to the right of it. All right, it's right in the middle. So it is not significant. Here's where our thinking should go. Okay, it's not significant, which means treatment or by random chance it happened. By random chance. So let's answer this question now. It wasn't by any sort of treatment. It was just by random chance. Ready? There was no effect observed between the two groups. If that was the case, do you know where all these dots would be? If there was no effect observed? Right here at 0. All of them would be at 0 if there was no effect observed. There was an effect observed that could be due by random assignment. What did we just go over? This was all by random chance. And read through 3 and 4. That's saying that one treatment led to bigger, larger plants. And we already know that that's not the case because it was in the middle. All right. Okay, you guys are all working on your own tomorrow. Stack those pieces of paper and put the paper clip back on for me. All in the groups tomorrow.